Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find the triangle area? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. Here is triangle ABC, and it is marked isosceles. The apex sits at B, where the two equal sides meet, and the base runs along segment AC. Our goal is the area of triangle ABC. The two equal sides, segment AB and segment BC, are each 7, and the base segment, AC, is 8. Those three lengths are everything we are given, so the whole solution must come from them. The area of any triangle is 1/2 the base times the height. We already have the base segment AC, so the one missing piece is the height dropped onto that base, and that is what we will build next. Drop a perpendicular from the apex B straight down to the base segment AC and mark the point where it lands as M. This new segment, BM, is the height we need, and it meets the base at a right angle. Our first insight is this. Symmetry makes the altitude a median. Half of the base 8 is 4, so the segment AM is 4. That length becomes one leg of the small right triangle carved out by the altitude. Look at the green triangle, ABM. Because the altitude is perpendicular to the base, its right angle sits at M, its hypotenuse segment AB is 7, and one leg segment AM is 4. The other leg is the height segment BM we are hunting for. In a right triangle, the two legs squared add up to the hypotenuse squared. So segment AM squared plus segment BM squared equals segment AB squared. This ties the unknown height to the two known sides. Subtract segment AM squared from both sides to get segment BM squared alone. Now the height squared equals segment AB squared minus segment AM squared. And both of those are numbers we know. The hypotenuse segment AB is 7, and 7 squared is 49. That is the first number we drop into the height formula. The known leg segment AM is 4, and 4 squared is 16. That is the second number, the one we subtract. 49 minus 16 is 33, so the height squared is 33. One square root away from the height itself. Take the positive square root to get the height segment BM as the square root of 33. 33 factors into 3 times 11 with no perfect square inside, so the radical stays exactly as it is. Now go back to the whole triangle, ABC. Its area is 1/2 the base segment AC times the height segment BM, and at last both of those quantities are known. Put the base 8 and the height square root of 33 into the formula. That gives 1/2 times 8 times the square root of 33. 1/2 of 8 is 4, so the two numerical factors collapse to 4. The height radical is simply carried along. So the area of triangle ABC is 4 times the square root of 33. The radical cannot be reduced any further, so this is the exact area. A second insight now finishes the structure. Two congruent halves. Check the area. Checking the legs, 4 squared plus the height squared is 16 plus 33, which is 49. Exactly 7 squared. The height is fully consistent with the given side 7. For a sense of size, the square root of 33 is about 5.7, so the area is roughly 23 square units, a believable size for this triangle. So the answer is 4 square root of 33. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.